Good morning, everybody. I'm saying good morning because it is now 12:17 a.m. I have been attempting to record part 2 on this video for about 4 hours now. This is my 4th attempt at it, and I hate everything. Let's do some math. So, example set 2. Simplify each radical expression with variables using perfect squares. I'm going to try my best to go through this as clearly as I can. I am exhausted. I've tried going through this multiple times already, and you don't get to see all the wonderful times I've attempted to do this for you already. So let's see if I can get through it this time and actually have it record and actually have it upload. So the first problem, I have just w squared in a square root symbol. When we're solving this, you have to think about your exponent rules that we covered earlier in the year. So like if I gave you, for example, if I gave you w times w, the answer to that would be w squared, because I add the ones that are technically in the corner here. If you notice, when I do this, I chose this intentionally because w to the second power is what the answer to this is. What variables do, because variables can be any number, because variables can represent any number, variables are very, very easy to work with, but the problem with them is that there's a very specific pattern that you need to look for, and if you're not looking for this pattern, problems with variables are awful. Here's the way that I would look at this problem. W squared with the square root basically means what multiplied by itself would make w squared. So if you look at this problem, if I do this and put the square root symbol around it, it's just saying, hey, work backwards. What two things multiplied together make w2 that are the same? W to the first times w to the first, these are identical, and they combine to make this. So my answer to this is going to be just w. This is probably going to look really confusing, and most of you are probably frustrated and angry that this is the answer. I'm going to go through and plug it in with a number and show you why the answer is just w. Let's say that instead of w, I said that this was 4, that this was radical 4 squared. 4 times, this would mean 4 times 4, which makes radical 16. Radical 16 is a perfect square. Simplifies to just 4. If you look at my original problem, I started with 4 squared inside a radical. 4 times 4 makes 16, and I end with the same thing I started with. I just don't have that extra radical symbol or exponent. This is the same thing. I started with w squared, and I ended with just the w. This works the same way. Plugging a number in helps explain this. Because this happens with variables, you're not always going to get a nice numerical value to explain it because variables can represent any number. I'm not going to make you go through and plug in an example like this to justify your answer. I just want you to recognize the patterns and why variables sometimes are really nice and sometimes they really suck to work with. This next one is x to the 4th. If you remember our exponent rules, I can make x to the 4th by saying x to the 1st times x to the 3rd makes x to the 4th because I'm adding the corners. I could also say that x squared times x squared makes x to the 4th because 2 plus 2 makes 4. When I'm solving these and thinking about perfect squares, I want these two exponents to be identical. I'm only working with one variable. The only thing I'm going to have is x. That's the easy part. What I'm trying to do is just divide this number into two numbers that are identical that would add up to this. 2 and 2 add up to 4. My answer to this is just going to be x squared. If I did x squared times x squared, I get x to the 4th power. If you notice, I'm also following this same pattern. And this pattern is going to continue on C and D, and I'm sorry if I'm not making the most sense. I am extremely tired. W is the same as w to the 1st. 1 is half of 2. 2 is half of 4. That same pattern is going to follow here. If you see an even variable, you can just divide it by 2, and that's your answer. I can think about, there's a whole set of different numbers I can add together to make 8. I can use 7 and 1, 2 and 6, 4 and 4. What I want to do is use two corner numbers, my two exponents that are identical. I would call this x to the fourth times x to the fourth would make x to the eighth. My answer to this is going to be x to the fourth. If you wanted to plug a number into here, and I am not going to do that, if you plugged in a 4 here and did 4 to the 8th power, and then hit the radical button to that large number answer, you would get the same thing as if you did 4 to the 4th power. Again, radical symbols and exponents have a relationship where they cancel each other out and you can move from one to the other interchangeably using the symbols. That's why a lot of these are continuing to have exponents after the radical's done. This next one, w to the 10th, I can think about that as w to the 5th times w to the 5th. That's going to be my answer. Next one, these two don't work with that pattern we've been doing of cutting it in half. What I need to do is come up with a new pattern that works for these. And there is a new pattern when you're working with numbers that are odd, but also numbers that aren't going to divide evenly at all. So with this problem, anytime you have an odd number, an odd exponent inside the radical symbol with a variable, there's a pattern that you want to follow, and this is what you want to do. Break this apart so that you have the largest even number you can have, and then just a 1. A good way to think about this problem is if we go back to the first problem we solved is radical 12. I'm going to review this problem. I broke this down to radical 4 and radical 3. I couldn't do anything with the radical 3 because it's not a perfect square. It stayed in my final answer. 4 as a perfect square, there was 2, so my answer was 2 radical 3. This problem's going to do something similar. I'm going to break this down to w to the first as one of them. That's a pattern I want to do for every odd exponent. The other, if I do 3 minus 1, I get w to the second. That is exactly what I solved up here. W to the second ended up being w times w, or just w. So this becomes just w. The w squared kind of acts like my 4. 4 broke down to a perfect square, went to the outside. This breaks down to a perfect square, goes to the outside. My final answer here is going to be the w that was broken down from this, and then the radical w that I can't do anything else with. Does this look confusing? Yes. Are you frustrated about this being the answer? Probably. Are we going to spend 2 days on this? Yes. Is your homework today going to be multiple choice so that you have a better idea of what to do? Also yes. Next one, y to the 5th. My first rule with this is break it down so that one of them is 1. The other one's going to be whatever remains. Any even number exponent is going to be able to be broken down to a perfect square because an even number can be divided by 2 to give you 2 identical numbers. This is going to stay with my answer. It's kind of like the radical 3 from earlier. This radical 4 is going to break down to just be y to the second because I can say y to the second times y to the second makes y to the 4th. I'm sorry if I'm explaining that too much. I'm incredibly tired. My answer to this is going to be y to the second radical y. If you wanted to put the 1 here in the corner, you can. I'm not going to stop you. Your multiple choice problems are not going to have that there. So if you want to put them, you can, but I'm never going to make you do that. I'm also standing up to make sure this is still recording because 4 times that I've done this, it's cut out here, and we're still recording. Next one, z to the 9th. My pattern is break it down so that it has something to the first power, which is going to stay in our answer. The other part's going to be z to the 8th. I can break that down to just be z to the 4th plus z to the 4th. It shows up twice, so it comes outside as a regular part of my answer, and then the z stays inside. If you double this and add 1, you get your 9. If you double this to 4 and add 1, you get your 5. If you double this to 2 and add 1, you get 3. Again, a pattern. Jumping ahead, I'm going to skip k. We're not doing anything with 3 variables today. Next problem, I've got a number and variables. Just treat them as 2 separate problems. It's kind of like when we were doing our exponent rules and we had whole numbers and we had variables. Just work them one at a time. I would start by breaking down just the 50. Let's call that 25. Let's call that 2. So this breaks down to just a 5 and radical 2. When I start looking for my answer choices, if I was writing out my work, which I'm supposed to be doing, I'm going to put a little bit of a space because I don't know if these m and n's are going to come outside, if something's going to stay inside. I want to leave some space. M to the second power, remember, if it's even, I can just divide it by 2. 2 divided by 2 makes 1. That just becomes m times m. So a single m is going to jump outside here. N to the fourth is n to the second times n to the second, which makes it a perfect square, so n to the second jumps out. So my final answer is 5m n to the second radical 2. Next problem I, I'm going to break down 54. That's going to be 9 and 6. 6 is going to stay the way that it is. It's not a perfect square. No other perfect squares make up 6. This breaks down to just 3. So right now I have 3 and a radical 6. B to the fifth breaks down to b to the fourth and b to the first. Remember that b to the first is going to end up in our answer, so I'm going to put a b next to the 6. My b's look like 6's. My 6's look like b's. If you haven't caught on to that by this time of the year, it's not going to change. B to the fourth breaks down to b squared times b squared, so that can be written down at the outside. C to the second power is even. I can divide it by 2. C squared can be broken down to c times c, so 1c comes out and I'm finished. This last one, I'm going to start with the 40, break that down to 4, which is a perfect square, and 10, which is not. This breaks down to 2, so I'm going to have 2 and that radical 10 left over. X to the 8th can be divided by 2, so that's x to the 4th times x to the 4th. Those are written twice and they're identical, so it can be written to the outside one time. Y to the 7th, I'm going to break down as y to the 1st and y to the 6th. The 6th can be broken down to y to the 3rd times y to the 3rd, which can come out like this, and this y to the 1st gets dropped back in. These problems are going to be confusing. I'm expecting you to email to me today if you need some help. Also with these, we're going to spend 2 days on this, and tomorrow's notes are not going to include anything different. It's just going to be practicing this again. You have to show your work. You have to email it to me. This is going to be the easiest day that we have. If you do not follow these patterns and know how to break these down, you are not going to be able to do the rest of this chapter, because from here we're going to be adding, subtracting, multiplying, and dividing like terms. If you can't get it down to this efficiently and knowing how that works, the rest of the chapter is going to be a very big struggle. I want to take this slow, so please make sure that if you need help, you ask for help today, because this is our last chapter. There's not going to be something else to come along and help improve your grade. This is the last topic we have.